Ram Dore. So today I am going to explain about our IC2 of heat and mass transfer. So problem statement is given as to we need to design the counterflow double pipe heat etc. So we will design further. Okay, so next first one is design constraint and parameter. So as per my roll number, I have calculated the inner pipe diameter, outer pipe diameter. So that comes around 18 mm and 20 mm. My length is come around 2 meter for the pipe, and inlet temperature of hot fluid that is 75 degrees Celsius. That is given in the problem statement itself. So cold fluid inlet temperature as per my roll number by calculating this, that comes around 26 degrees Celsius. After that, flow rate comes around 0.055 kg per second for hot fluid, and for cold fluid that is 0.05. So this is the schematic diagram I have generated from the AI, but the all values that we have calculated that shown in the figure itself. So we will see the further the calculation. So I have calculated the heat performance of total heat transfer, that is comes around 5525.52 watt, and heat capacity rate that comes around 170 watt per Kelvin for water. For water that is 230.2 watt per Kelvin. So I have calculated effectiveness also. So that comes around C value comes around 0.73, and effectiveness of this system is comes around 0.66. That's under the our limit, so that is 1. So it is we can that is under the limit. Next I have calculated the NTU, that comes around 1.561. So required area calculated, that comes around the 0.90 meter square by LMTD, and by NTU that comes around 0.97 meter square. So available area we have only 0.11 meter square based on the 2 meter length. So next is design evaluation and costing. So I have selected material as a stainless steel because it has the balance of durability and cost. And as an insulation, I have selected the glass wool because I have also some cost constraint. So I have derived the breakdown the cost here. So for pipe that is around 1,100, 500 rupees per inner for inner pipe, and 600 rupees for outer pipe as per the diameters. For insulation that is 26 rupees. So total cost is 1,126. For total budget we can say that is the in 1,300 we can design this system. Next is the justification of our system. So material choice for stainless steel is corrosion resistance and the more economical feasible than the copper, while providing the longer service life. Thermal stability, the use of glass wool insulation is justified as it has the very low thermal conductivity, ensuring the majority of heat transfer occurs between fluids and the non-environment. So economical viability, that is the design meets all the performance of objective within the set budget. That's why I have selected these materials only. So next is I have simulated the our problem statement by using ANSYS software. So that also the temperatures comes around the whatever we have calculated the by using formula. So by using ANSYS I have validated the this heat system. So next last is the conclusion. So the design successfully meet the cost constraint that is 1,126. So limitation, the available surface area is 0.11 meter square, is roughly 9 times smaller than the required, that is 0.97 meter square. So final material and the insulation are optimal optimal, the budget, the physical size must be increased or enhanced with the fins or meet the thermal requirements. Thank you.